Alright, so in this video, I'm going to solve the problem 2 to the power of 25 minus 2 to the power of 24. So to solve this, I'm going to first start by rewriting 2 to the power of 25 as 2 to the power of 24 plus 1. So I have this minus 2 to the power of 24. And the reason I did this is because we want both of these to be the same. We want to have 2 to the power of 24s. So the best way of changing 2 to the power of 25 as 2 to the power of 24 times something is to rewrite this as 2 to the power of 24 plus 1. So now I can use the property a to the power of m plus n is equal to a to the power of m times a to the power of n. So now 2 to the power of 24 plus 1 turns into 2 to the power of 24 times 2 to the power of 1. And I still have this minus 2 to the power of 24. Now, from here, what I'm going to do is factor out 2 to the power of 24, because notice how both of these terms have 2 to the power of 24 in them. So, I get 2 to the power of 24 times 2 to the power of 24 times 2 to the power of 1 divided by 2 to the power of 24 is just 2 to the power of 1. And negative 2 to the power of 24 divided by 2 to the power of 24 is just negative 1. So I get 2 to the power of 24 times 2 to the power of 1 minus 1, which is equal to 2 to the power of 24 times 2 minus 1, which is equal to 2 to the power of 24 times 1. And this is just anything times 1 is obviously just equal to itself. So this is just equal to 2 to the power of 24. Now, from here, I'm going to rewrite this as 2 to the power of 12 times 2. So, the reason I did this is because I can now use the property a to the power of m times n is equal to a to the power of m to the power of n. So 2 to the power of 12 times 2 is equal to 2 to the power of 12 to the power of 2. And 2 to the power of 12, well, 2 to the power of 1 is equal to 2. 2 to the power of 2 is double of 2 to the power of 1, so 4. And 2 to the power of 3 is double of 2 to the power of 2, which is 8. So this pattern goes on, and I keep on doubling this. Until I reach 2 to the power of 12, which is equal to 4,096. So this is my value for 2 to the power of 12. So now I get 4,096 squared. Now, what most people would do, well, first of all, 4,096 squared is the same thing as 4,096 times 4,096. And from here, what most people would do is they would just multiply this like this. So they do 4,096 times 4,096 and use the conventional method to multiplying it. However, this method takes way too long, and it's really easy to make an error using this method. So instead, to more easily solve this, I'm going to rewrite this as 4,000 plus 96 times 4,000 plus 96. And now I can use the distributive property. So I get 4,000 squared plus 4,000 times 96 plus 4,000 times 96 plus 96 squared. Now, from here, $4,000 squared, well, this is simple because all we have to do is 4 squared, which is 16, and then 1,000 squared, which is a million. So a million has 6 zeros, so all we have to do is add 6 zeros to the end of this. So I get 60 million, it's 4,000 squared, plus 4,000 times 96. Well, 4 times 96 is 384, so then all we have to do is add 3 zeros to that. So I get 384,000, and then this should be 4,000. So plus, again, 4,000 times 96, which is 384,000, plus 96 squared, which is 9,216. So now all we have to do is add all of these up, which is fairly simple. So I get 16 million plus, let's first start by adding up 384,000 plus 384,000. So that's going to be 768,000 plus 9,216. And now this is equal to 16 million plus 768,000 plus 9,216, which is 777,216. And now for my final step, I just have to add this to 16 million. So we don't have to worry about the millions place, so I just get 16,777,216. So this is my answer to this problem. Now, if you haven't already, please make sure to subscribe and leave a like because I have many more videos like this on my channel, which you guys can try to solve. And if you're up for challenges, I have a bunch of those as well. So please make sure to subscribe, and thank you. Bye. Alright, so in this problem, I have x to the power of 9 plus x to the power of 6 is equal to 36. So I want to find the value of x here. Now, x to the power of 9, I can rewrite as x to the power of 3 times 3, and x to the power of 6, I can rewrite as x to the power of 3 times 2. So I get x to the power of 3 times 3 plus x to the power of 3 times 2 is equal to 36. Now from here, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 3 times 3, that's equal to x to the power of 3 to the power of 3, and x to the power of 3 times 2, that's equal to x to the power of 3 to the power of 2. And this is equal to 36. Now I'm going to let x to the power of 3 equal to the variable t. So I get t to the power of 3 plus t squared is equal to 36. And now if I subtract 36 on both sides, I get t to the power of 3 plus t squared minus 36 is equal to 0. Now to solve an equation like this, what we have to do is first find one solution and use that solution to find the remaining solutions. And to find that one solution, we just actually have to plug in numbers and see if they work. So I'll first start with t is equal to 1. If t equals 1, I get 1 to the power of 3 plus 1 squared minus 36 which does not equal 0. If t equals 2, I get 2 to the power of 3, which is 8, plus 2 squared, which is 4, minus 36, which again does not equal 0. Now if t equals 3, I get 3 to the power of 3, plus 3 squared, minus 36, which does equal 0. So t equals 3 is a solution to the equation. Now what we can do with t equals 3 is divide t to the power of 3 plus t squared minus 36 over t minus 3. And whatever equation we get from this is what we have to factor out and find the solution to. So how do we divide these two? Well, t to the power of 3 plus t squared minus 36, I can rewrite this as t to the power of 3 minus 3t squared plus 4t squared minus 36. And from here, I can factor out t squared from t to the power of 3 minus 3t squared, and 4 from 4t squared minus 36. So I get t squared times t minus 3 plus 4 times t squared minus 36. And t squared minus 36 is the same thing as t plus 6 times t minus 6. Sorry, this isn't supposed to be 36. This is supposed to be 9. So I get t plus 3 times t minus 3 is equal to 0. Now, from this whole thing, I can factor out t minus 3. So I get t minus 3 times t squared plus 4 times t plus 3, which is equal to t minus 3 times t squared plus 4t plus 12. Meaning, t to the power of 3 plus t squared minus 36 divided by t minus 3 is right here, t squared plus 4t plus 12. So now this gives me two equations. I get t minus 3 is equal to 0, and t squared plus 4t plus 12 is equal to 0. So obviously t minus 3, we already know the answer to that is t equals 3. But for t squared plus 4t plus 12 is equal to 0, to solve this we're going to have to use the quadratic formula. So I get negative 4 plus or minus the square root of b squared, so 4 squared, which is 16, minus 4 times a, which is 1, times c, which is 12, all over 2a, so 2 times 1. And this is equal to negative 4 plus or minus the square root of 16 minus 48 over 2, which is equal to negative 4 plus or minus the square root of negative 32 over 2. And this is equal to negative 4 plus or minus the square root of 32 times the square root of negative 1 over 2. And the square root of 32 is the same thing as the square root of 16 times 2, which is the same thing as the square root of 16 times the square root of 2, which is the same thing as 4 root 2. So this is equal to negative 4 plus or minus 4 root 2, and the square root of negative 1 is the same thing as I. And I have this over 2, and now if I divide this by 2, I get negative 2 plus or minus 2 root 2i. So t is equal to negative 2 plus or minus 2 root 2i, as well as 3. Now, we're not done yet, because remember how we let x to the power of 3 equal to t. So I get x to the power of 3 is equal to 3, and x to the power of 3 is equal to this. However, we can't take the power of a number and make it have an imaginary solution, so we cannot use this solution of t. So the only solution we can use, x to the power of 3 equals 3, and if I take the cube root on both sides, I get x is equal to the cube root of 3.